Solving rational equations. So we have x over 5 is equal to x plus 3. Let's change that to a different color. We can use green. So here we go. Here we're going to use the cross multiplication. So that's going to be x times 8 is equal to 5 times x plus 3. Now x times 8 is going to be 8x. And 5 times x plus 3, we use a distributive property. 5 times x equals 5x. And 5 times 3 is equal to positive 15. So we're going to do plus 15. And now we're going to isolate our variables. So we're going to get our x's to one side and our constants to the other side of the equal sign. So we're going to put this 5x to the left. And to move something to the opposite side of the equal sign, we do the opposite operation. Here we have a positive 5x, so we're going to subtract 5x from both sides. 8 minus 5x equals 3x. And then we're just going to bring down everything else that wasn't affected. 15. Now remember, we're going to isolate the variable. So to get this x by itself, we have to get rid of that 3. And to get the 3 on the opposite side of the equal sign, we do the opposite operation. Here, 3x means 3 times x, so we're going to divide by 3 on the both sides. And that's going to leave us with x equals 5. Let's check our answer. 5 over 5, because we're substituting the number 5 everywhere we see x, equals 5 plus 3 over 5. Plus 3 over 8. Is that true? Well, 5 over 5 equals 1, and 5 plus 3 equals 8 over 8, which equals 1. Which will give us 1 equals 1. And that is true. So this one is correct. Let's go to the next one. 4 over 3x plus 3 equals 12 over x squared. So I'm going to change this color here. Make that dark blue. Now here we have a difference of squares. So we have 4 over, let's factor 3 out of x plus 3, so x plus 1 equals 12 over, let's not forget our parentheses, x plus 1 times x minus 1. Alright. Now let's find our least common denominator here, or our greatest common multiple. So we're going to do 4 over 3 times x plus 1, x minus 1, and we're going to multiply that by x plus 1 over x plus 1. Equals 12 over x plus 1 times x minus 1 times 3 over 3. Which is going to give us 4 times x plus 1 over 3 times x minus 1 times x plus 1 . All we're doing is finding an equivalent fraction to manipulate the denominator so that we can have the same denominator on both sides of the equal sign. And then we're going to do 12 times 3 over x plus 1 times x minus 1 times 3. Remember, since we are multiplying, it doesn't matter the order that the numbers are in or the expressions are in. Just because the 3 is at the front here, the 3 is at the back here, does not change the value. These two are the same. 3 times x minus 1 times x plus 1 is the same as x plus 1 times x minus 1 times 3. Now that the denominators are the same, we know that this expression is equal to this expression. Something else we can do is just change the color here. Like that. So these two expressions here are equal to one another. So we can rewrite it as 4 times x plus 1 is going to be 4x plus 1 equals 12 times 3 is 36. 12, 24, 36. Now we're going to isolate the variable, get the letter by itself. So we're going to subtract 1 from both sides. Minus 1. And 4x equals 35. These two cancel. And then we're going to divide by 4 on both sides. And our final answer is going to be x equals 35 over 4. We can leave it as an improper fraction, or we can turn it into a mixed fraction. 4 goes into 35, 4, 8, 12, 16, 20, 24, 28, 32. 4 goes into 35, 8 times. And then 8 times 4 is 32, and 35 minus 32 is 3. So as a next fraction is 8 3/4.